This is the bridle steering staging video where we'll walk through the main components of the bridle steering system and how they are connected together. You'll receive a rack mount controller. This controller drives the motors on the gun race using high voltage and has a sensor return from the rotation sensor on the winch to know the position of the winch. This also has a server, which is a Linux based server which can control this device using a network application. We got a 19-inch screen, mouse, keyboard which go with the server assembly. We have rotation sensors, look like this, which get mounted on the winch themselves with the 4 bolts. And we have what we call target magnets. Typically you would put 4 of these on each winch drum, and these magnets must pass within a few millimeters over these particular black sensors, so that the sensor passes a few millimeters over this as the drum rotates. So they must be mounted to be within 2 or 3 millimeters of the face of this magnetic sensor here. This sensor will detect the direction that the magnet passes and will send information to the controller as to whether the winch has turned clockwise or anti-clockwise, or hoist or slack. This rotation sensor has 2 connections. Pin 1 is positive and pin 2 is negative. This is a 24 volt sensor and it consumes different amounts of current depending on the activation of these devices here. So these 2 wires must be wired through the gun umbilical to the pin connectors on the back of the controller, which I will show you momentarily. So this rotation sensor, as does the target magnet, will be supplied with 5mm countersunk screws, stainless steel, A4 stainless. They will be mounted on the flange like so, and the flange needs to be modified with this rotation sensor and the connector flush so the magnets pass by the rotation sensor. On the outside we have LEDs that are visible, green and red LEDs, so you will see those illuminate as the rotation sensor passes. It gives you a visible clue, especially if the drum is enclosed. It will give you a visual indication that the magnets are passing successfully past this sensor. Okay, so on the back of the controller, which I will turn around now and we can have a look, are several connections, most of which are unused for most installations. Okay, these are 4-pin DIN connectors. There is one for every subarray or every winch. It is a 4-pin connector, and I will show you going around the connector. We have this pin here is the positive high voltage, the negative high voltage. These high voltages drive the solenoid for the air powered winch. It inverts the polarity to drive in the other direction, so you will need to have a splitter with a diode inside if you have 2 valves, to make sure that a positive polarity activates one solenoid and a negative polarity activates the other solenoid. This pin here is the positive for the rotation sensor, that's plus 24 volts, and this is the negative side of the rotation sensor. So we have these connectors which are to be wired by the client. So these, you need to disassemble this connector, place your wiring to your patch panel, which will be routed all the way down the subarray to the sensor, the rotation sensor, and to your solenoid valves to control your air pressure. The high voltages on here start off at 120 volts and then they decay to have a holding current of about 0.7 of an amp to hold the solenoid open. They are compatible with Bolt airgun solenoids, which are operated at low pressure. Okay, so the connectors themselves push in, and there is a rotating ring to lock them in place. We've found that these are very reliable connectors. On the back we also have COM1 connects to the server. So this is an RS-232 cable which takes commands from the remote server and replies with data. So this is the communications with the server via COM1 on the back panel. We supply the D9 cable. It's a 1 meter long cable, so it can connect from this connector to the COM port on the back of the server. That's installed there. Locking jacking screws. And we also have AC input, 100 to 250 volts AC. We supply the IEC connector for that. This is a standard IEC connector. Okay. So the server is connected up. Let me just turn this around. On the front panel you will see that we have 4 buttons. This is to operate the system in the absence of the server, and also to do some configurations. We have a key switch which is safe and enable. When the key switch is vertical, it's in the safe mode. Power has been removed from the high voltage back plane, so the winches cannot be activated. That's very important for safety purposes. If the gun mechanics are working on the gun arrays, you don't want to be sending 120 volts down the gun array. So always have it in safe mode when in operation, and when safe mode when it's on board or being worked on. Clicked over to enable. That applies power to the back plane, and the winches can then be driven. Okay. Turning on this device, there is a single switch on the front panel. Place it in the 1 position. The system will start up. You'll see the LEDs toggle, splash screen, and the system will start. It will cycle through several pages of information as they start, and it will actually show information on the graphical information. In this case, 6 winches have been set up, and it basically will cycle through a splash screen and whatever pages have been set up in the menu. To control the system, pushing any button will bring up the menu. If you push a button, you see you have a menu where you have view settings, system settings, control the winches, or quit the menu. Pushing quit takes you back to the main screen again, and the system will cycle through pages of information just for display purposes. In the control menu, you can select the channel at the top. In this case, channel 2 has been selected. This shows the settings for channel 2, and you can physically drive the channel in or drive the channel out. That will rotate the winch manually. So physically you can hold down the drive in button, and you'll see this is channel 2 has been activated here, and you'll see the LED flashing slowly to say that the winch is being driven in. When you push the drive out button, the button will flash quickly to indicate it's being driven out. If you wish to drive another channel, you can change this channel here by pushing the set channel button. So it's changed to number 3. You can push drive in, and you see that the LED is flashing. High voltage after 2 or 3 seconds will be applied on the output, and to drive out, push the other button. So that's a way that manually this device on its own can be used to manually drive the winches in the absence of the server, if there's a problem with the server. Push the back button and then push the quit button. There are all sorts of settings that can be changed on this device. They are gone through in great detail in the manual. Okay, the server, I will show you how that works. First thing first, power on the server by pushing the power button on the front. The server will boot up, and I will show you how the control system works for the server. booting up Fedora. We're using a Fedora operating system, Fedora 14 in this case. That is the standard operating system that's compatible with the Bridle steering software. When the server has been powered on, you will get the login screen. There's only one login, it's Seismic Stuff. You click on that, and the password is Seismic Stuff with no spaces. SEISMICSTUFF. Login. This takes you into the system. And after a few moments, you will see a desktop. Moments, I should say. Okay, there are two icons on the desktop which are used to launch the application. The first one is called SSC Server, and this is SSC GUI. The SSC Server must be running. This is a application that allows communication between the server hardware and the rack mount controller. The GUI can be run on this machine or anywhere on the network. I will show you how that can be configured. First thing first though, we must launch the server program. So this must always be running. Double click on the launching icon. And you'll see instantly that you have communication hex dump between the server and the controller. You'll also see a message on the screen saying that there's incoming data. That indicates that it has an ongoing communication with the server and is answering questions and queries and sending the answers back. Okay, so now that the server process is running, we can launch the GUI program on any PC on the network. I will launch it on, in this case, on the server. Well, it's not so impressive, but we will show you how that works. So the Java program is running, connects to the database on this machine, which is the method by which it communicates, and it shows a screen which indicates the position of the winches and the preset positions. So this application is configured to allow a touchscreen computer on the back deck, should it so be desired, or from the instrument room using a mouse control. So this shows the collar on each umbilical and a graphical indication of a winch. This is channel 1, 2, 3, 4, 5, 6. It will only show the channels that are enabled on the controller. The controller can have up to 8 channels, but because the system has been ordered with only 6 rotation sensors, we've only enabled 6 channels, but that can be changed in the settings. Okay, so the way that this user interface works is that either a command can be sent to the controller to move the winch a certain number of magnets, count of magnets, in or out, and this is the drive using the rotation sensor in counting mode. So you can set the direction. This indicates hoist, this indicates that we're going to count rotation sensor clicks, and this is the number of clicks. So for example, if you had 4 magnets on your drum, on the winch drum, then you would, selecting 4 here would mean 1 complete rotation of the drum. So in that case, by clicking the execute command, which is the tick box, the motor would actually turn, would enable and would actually rotate for 4. Here we see the winch is now powered on as engaging. You'll see that there's a flashing light here to say the motor is now being driven, and it will stay on until you have hoisted, you have pulled in 4 clicks on the magnet. Okay. We don't have any rotation sensors attached at the moment, but if they were, you would be able to, the winch would turn, it would count up 4, this would move up the screen. Okay, we can stop in an emergency, or if there's a reason to stop, there is this picture of a hand which says halt. Clicking on that will stop the winch. So having clicked on that, you notice the winch has stopped here, the winch's controller has stopped being driven here. There is another way. Sometimes the rotation sensors become damaged over time. There are problems with it. You don't believe that they're working, or the system gets a bit stuck because it's maybe gone beyond the bounds that are allowed. So it is possible to turn on the winch, turn on the power to winch just a certain number of seconds. You just want to apply a few seconds and get it to turn irrespective of what the magnets are indicating. By clicking the picture of the clock, you can drive for a certain number of seconds. So in this case, we've selected 4 seconds. This is time, number 4 means 4 seconds. This is hoist, we'll just drive it in another direction just to example. This means slack, the arrow pointing away from the winch. Clicking on the tick executes the command. You will see that the winch would be driven and it would be driven out. Now you'll notice that the motor is flashing for 4 seconds. Now let me do that one more time. It was flashing for 4 seconds on the screen. Again, flashing here, indicate flashing, it will run for 4 seconds and then will stop. There you go, it has stopped after 4 seconds. Okay, we have preset positions. So often once a system is set up for deployment of the gun arrays and for recovery of the gun arrays, you might have preset positions. You can adjust where they are, but they're shown by these indications here. And to get the system to drive the collar to that position, all you would need to do is to physically click to this position here. It says to the fully deployed position. The system will actually turn on the winch and will continue to drive until the collar gets to that position, and then it will stop automatically. It knows where it is, it counts the number of clicks of rotation magnets rotating and clicking past, and it will stop when it gets to the correct position. In this case it won't stop because we don't have a winch. We can hit the halt button and the system will stop, and if we wanted to go to this position, we would just click the blue button and the system will off we go, would run. We can adjust many of the settings for this channel using this dialog box button here. So if we click on this button over here, we can adjust the settings for channel 1. So clicking on that pops up a dialog box, and you will see that there are a minimum, the preset 1 position, the current count. So when you first calibrate the system and set it up, you need to set this up manually. There's the preset 2 position, and there is the maximum position here. Typically you would want to set this to be a small positive number for the minimum, and the maximum amount wound onto the drum so that the shackle doesn't jam into the eye on the end of the drum. So these numbers need to be set beforehand for the winch. Okay, and there are abilities to use the current position of the winch. So for example, if you manually drive the winch out, you can use the current position and start entering them that way. There's the ability, sometimes the solenoid drive you would have inverted, or the cabling is inverted, or the air hoses are inverted compared to what the system expects. You can have the option to reverse the motor drive. In this case, they're all engaged. Turning them off using hoist would be slack, and slack would be hoist. You need to get these the correct way round, and also you need to get the rotation sensor counting in the correct direction. When you hoist the device, the count needs to increase. When you deploy the winch, the count must decrease. And they can be set, if they're the wrong way around, you can reverse the rotation sensor. It's not a polarity correction, it's just a count correction. Okay. When we click apply, it sends those current pieces of information to the controller, and the controller will save them in memory and we'll use them from that point on. Okay. In this case, if we're going to cancel that dialog box, nothing gets sent to this device. Okay, that pretty much covers the use of the graphical user interface, but I will quickly cover the settings file which is used for that. So if I close this and I will stop the SSC server program, just close the window. Okay, if we look in the Seismic Stuff home directory, double click on that folder, then you will see that in the home directory we have the SSE GUI jar file. This is the Java graphical user interface. We also have an application called SSE server. Okay, so SSE server is the program that runs only on the server. But the jar file can run on any Windows machine on the network or any Linux machine on the network. Associated with this jar file is an images directory, a library, and audio file. So the audio file contains some spoken clues as to what the system is doing. We also have the images directory contains all the graphical images which the system uses, so that must be copied across. And we also have the library which contains the SQL connector, which is a Java bin file. So this is a part of the software that's shared. Okay, so if you wish to run the Java software on another machine, you must copy across the jar file, images, library, and the audio directory to your machine, and they can be run from any machine on the network. Associated with this file is also a text file called settings. This must be filled in to be correct. I will show you what's inside the settings file. There are 4 lines inside here. The first one is the IP address of the server. In this case, on this machine, this is just the home IP address, 127.0.0.1. On another machine, this IP address must be changed to be the fixed IP address of the server. I will show you how that's changed. SSC is the name of the database. Seismic Stuff is the login to the SQL database. Seismic Stuff is the password. And this is every 1,000 milliseconds the database will be polled for changes. So the graphical user interface will be updated. So I suggest that if you are running this on another machine, you would copy across the settings file. This must be in the same directory as the jar file is launched from, and that file will be run over here. Okay, so this settings file will be read, and the jar file will then connect with this IP address, this database, and logged in using Seismic Stuff and Seismic Stuff as a password. Okay. We also have the settings for the network. I will just show you how that is done. At the moment, the system is connected to the network. In preferences, we have network connections, and you will see that we have lots of Ethernet adapters. This one is Ethernet 2. I can edit that. I happen to know that's the one that's being used. If you go to the IPv4 settings tab, here you can set the IP address of your server. It needs to be a fixed IP address, the net mask and the gateway for your vessel. Notice we're using 192.168.0.123 on our internal network in our office. So if I run the SSE server software here and I move across to another machine in our office,
on another PC on the same network, copy over the Bridle steering software.
okay, on another PC on the network, this is a Windows PC running Windows 7, we can launch the settings, have a look at settings, and in this case you'll notice the IP address 192.168.0.123/SSC. That's the IP address of the server, which is over there, and this is the login, seismic stuff, and 1000 milliseconds polling. When we have the SSC GUI, which is a jar file, we have the library, the images, the audio, and the settings are all in this particular directory. Just double clicking on the jar file will run the software.
Welcome to Seismic Stuff Technology Source Control System.
That this machine has audio and it shows the current settings on the system. So this is now connected to the database which is over there. Okay. So for example, if we want to drive to a certain position, we can drive to that position.
Drive to preset 1 position.
Then the system will be driving the winch. Again, it's driven here, and you'll notice that if we come across to this device here, that even remotely the winch is being driven from that remote machine. Okay, that pretty much wraps up how the bridle steering system works. Thank you very much for your attention.